Okay. Now today's lecture starts from the washer method. So what is washer method? I will expand one by one. So the washer method is a method in which there are two functions are involved. Okay. So some of the solids is a definition or explanation. Some of the solids of definition have cavities in the model. So if there is a cavity means if there is two functions, let us say f of x and g of x, that is there are two functions, so both functions will vary from one point to another. So for this function we use washer method. So again, I'm elaborating when some solids of revolution have cavities in the middle, so they are not solid all the way to the axis of revolution. Sometimes this is just a result of the way to the region of revolution is shaped with respect to the axis of rotation. So in other cases, cavities arises when the region of revolution is defined as the region between the graphs of the two curves. Let us say two functions are f of x and g of x. A third way this can happen is when an axis of revolution occur, then the x-axis or y-axis is selected. Okay, so when the solid of revolution has cavity in the middle, the slices used to approach or approximate the volume are not disc but washers. So if there's a cavity, so washer basically disc with holes in the center. So for example, consider the region bounded for the graph. Let us say f of x equals to under root x and g of x equals to 1. And let us say the intervals or domains are 1 and 4. So how to do it? So let's move forward to, okay, so these are the two functions, or this is the first function, f of x equals to under root x and g of x equals to 1. As this is constant, so this means that a straight line. So a thin rectangle in the region between the two curves, let us say I am selecting any between this region, okay, any rectangle. After selecting a rectangle, so produce a washer. So it will be solid in this region, okay, and cavity in this region till 1, because there is no region in this area, so there will be cavity. So it will start from 1 and -1 will be my axis revolution reflection. So there's a hole between them, so it is known as washer. So washer method is used when there are two values or two function values with different values. So let us say we can select a rectangle between the curves, and after selecting the rectangle, I will produce a washer which is revolved around x-axis in this case. So this is the first case where x-axis. So let us say if there is I'm not selecting a region, I am selecting a hole. Let us say it is, I described that my interval is 1 and 4. So it is started from 1 and ended at 4. So it will be when the region between two curves is revolved about x-axis, so it will be a solid revolution. So it will be like cavity between this region to till this region, and a rotation here. So it will be drawn like this one, and there's a circular path for my rotation. Okay, and so there's a cavity between them. So this is a way basically we use washer method to find the volume of my surfaces. Okay, let's move towards. So for this case, the cross-sectional area will be the between this function to this function. So this function will be my upper limit, so it will be pi r square, and here it is also pi r square. Okay, so these are the four things to remember. So first function is, now I will area to find. First I will find the area. So area will be pi and then r square. So first case, r will be my function. So this is a function of f of x, pi r square minus pi second function, that is g of x square. Okay, so it will be pi f of x is under root x whole square. This square and this under root will be cancelled out, and pi 1 square will be 1. So I will take pi as a constant. So x minus 1. So this is the value of area with respect to a of x. Now after finding the area, I will find the value of volume. So volume will be equals to integral upper limit is b and lower limit is a, and it is integral with respect to area, so a of x. So my value of now upper limit is 4, lower limit is 1, and it will be pi x minus 1 d of x. I'm taking pi as a constant, so putting the intervals or integral on x minus 1. So it will be pi x square upon 2 minus x with the interval values 4 and 1. After putting it, the value is 9 upon 2 pi units cube. So for this, in this way, I will find the value of, or simply find the volume by using Washer method. Okay, so here we have to first find the area, and after finding the area, you can put in the taking the integral of volume. So after taking the integral of volume, I can find my respective answer. Okay, so again, by elaborating the Washer method, for my Washer method, there are two functions, f of x and g of x, such that this function f of x is greater than or equals to g of x and over an interval a and b, such that x equals to a and x equals to b. Okay, that it means that it lies on x-axis here or there. Okay, so the volume will be equals to integral of pi and then function f of x square minus g of x square. Okay, so this is the way to find the volume by using Washer method. So this is the introduction of Washer method. In the next topic, I will do the example related to Washer method. That's it. Please do it carefully, and I will take quiz on the in the next lecture.